Section 13.9, Formulas for the Tangent, the last section of Chapter 13, and unfortunately, or fortunately, more formulas to memorize and apply. Today we're going to use the addition, double angle, half angle formulas for the tangent. So get those flashcards ready. Add these formulas to your cheat sheet. Here we go. So the addition and subtraction formulas for the tangent. These are derived from combining the sine and cosine addition formulas. If you want to see how the book did it, you can go look in the book. But for now, all you need to see is that these are the formulas. The tangent of alpha plus beta equals tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. The tangent of alpha minus beta is equal to the tangent of alpha minus the tangent of beta divided by 1 plus the tangent of alpha tangent of beta. Now what you want to notice is that the numerator sign matches the operation sign between the two angles. So you notice that here, tangent of alpha plus beta, you have a plus in the numerator, and you have a minus in the denominator. When you are subtracting, you have a subtraction in the numerator and addition in the denominator. So that'll help you keep the two formulas straight. The double angle formula can be derived by using the sum formula and then combining the alphas together. So the tangent of 2 alpha is equal to 2 tangent alpha divided by 1 minus tangent squared alpha. So that's another formula you can use to memorize. If you do not remember this formula, you can always go back to tangent of alpha plus alpha and you'll get the same thing. Let's take a look at example 1a. Simplify this expression to a single angle. So tangent of 25 plus tangent of 15 divided by 1 minus tangent 25 times tangent of 15. So the first thing you want to do is figure out which addition formula are we using here. Well, you can see an addition sign in the numerator, which tells you that whether it's addition or subtraction, it is the addition formula. So all you have to do at this point is add the two angles together. This expression is equal to the tangent of 25 degrees plus 15, which comes out to tangent of 40. You do not have to solve for that. This is the answer that they want, an expression of a single angle, which is 40 degrees. So identify which formula you are using here. Look at the numerator sign and the denominator sign and draw your correct conclusion. 1b, 2 tangent 18 divided by 1 minus tangent squared 18. Take a look at this expression. Try to simplify this to an expression of a single angle. Alright, this is the double angle formula, which means tangent 18 plus tangent 18 over 1 minus tangent 18 tangent 18, or you can use the square formula, which is tangent 2 times 18 degrees, which is tangent of 36 degrees. So tangent of 2 times 18, because this represents 2 tangent alpha, 1 minus tangent squared alpha, so it's equal to the tangent of 2 alpha. Example 2a, find the exact value of tangent of 195. So you're going to want to use the tangent addition formula here. You're going to want to find two angles that we can add to 195 so we can know the exact values of the tangent for those values. Whenever you see a 5 here, you can pretty much assume it's going to have some multiple of 45 and 30. In fact, the easiest way to do it is probably to just take this number and separate it into 45 plus something else, which we'll do here with the tangent of 45 degrees plus 150. So we can figure out the tangent of 45 and the tangent of 150 because they have reference angles that are multiples of 30 or 45. So let's use the addition formula and plug in the values. So this is equal to the tangent of 45 plus tangent 150 over 1 minus tangent 45 tangent 150. Notice that this numerator operator matches the addition symbol here, and the denominator has the minus sign, which is the opposite of what you want in the original expression. So now let's just plug in the values. Tangent of 45 is 1. The tangent of 150 is equal to negative tangent 30, because this is in the second quadrant with the 30-degree reference angle. So the negative tangent of 30 is negative root 3 over 3. So we also plug those values in here. This 1 times this makes this 1 go away. To simplify this expression, we can convert the 1 here to a 3 over 3. So we get 3 minus root 3 over 3 in the numerator. This 1 we can also convert to 3 over 3. So we get 3, the negatives cancel, 3 plus root 3 over 3 in the denominator. Multiply the top and bottom by 3 and you're left with this. Now remember, you cannot have radicals in the denominator, so you multiply the bottom by the conjugate, which matches actually the numerator. So this gets you a squared minus 2ab plus b squared. A squared is 9, b squared is radical 3 squared, or 3, and 2ab is 2 times negative 3. So negative 6 root 3 in the numerator, 9 minus 3 in the denominator, you get 12 minus 6 root 3 over 6. Divide everything by 6, and you get 2 minus root 3. So you can figure out the exact value for tangent of angles by separating them into 45 degrees and some presumably multiple of 30, and just be very, very careful with the simplification process. 2b, find the exact value of tangent of 255. So you can do it with here, do this problem here. Again, use the strategy where you separate the 255 into an angle with a 45 and a something else. So if you use 45, the other angle is going to be 210, and you just do the same thing that you did in example 2a, which is tangent 45 plus tangent 210 over 1 minus tangent 45 tangent 210. So the tangent of 210, this is in the third quadrant with a reference angle of 30, which means tangent is positive in the third quadrant, and tangent 30 is radical 3 over 3, which we just figured out. So you plug those values in for 210, tangent 45 is 1. The nice thing about 45 for tangent is that it's going to equal 1. You don't want to pick complicated angles here. So doing what we did last time, now in the numerator we get 3 plus root 3 over 3. In the denominator we get 3 minus root 3 over 3. Again, we knock out the 3's by multiplying the top and bottom by 3. Multiply the bottom by the conjugate, and simplify to 2 plus radical 3. Just be very careful again when you do the simplification. Notice that this is very close to the answer in 2a. Next, we can find the half-angle formulas for tangent. Well, we're not going to find them. I'm just going to give them to you. You can derive them from using the half-angle formulas for sine or cosine. So if you do that, you see that the tangent of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. I will tell you, you will almost never use this because it's a mess. What you could do is use one of these two. Tangent of theta over 2 is equal to sine theta over 1 plus cosine theta, or tangent of theta over 2 equals 1 minus cosine theta over sine theta. I will tell you that unless you're using cotangent, you're almost always going to use this bottom one. Why? Because it's simpler. You only have one expression in the denominator. The expression in the denominator is almost certainly going to have a radical in it because sine and cosine are usually going to have radical 2's or radical 3's. So you're almost going to want to use this formula exclusively. You might get a problem with the cotangent of theta over 2, in which case you will use this one because you're going to have to turn it upside down because the tangent is the reciprocal of the cotangent. So you'll probably never use this formula, but if you want to remember it, that's fine. You are going to use one of these two. Notice tangent theta over 2 equals 1 minus cosine theta over sine theta. Tangent theta over 2 equals sine theta over 1 plus cosine theta. These are derived by basically multiplying the top or bottom by either 1 plus cosine theta or 1 minus cosine theta. Alright, let's do example 2b again. I just went over some of the formulas used, some of the problems using the addition formula, but there is a little trick. You can generally use the half-angle formula to solve these problems, and it might even be a little easier. So let's use the half-angle formula, but we'll use theta equals 510 because theta over 2 will be 255. So the tangent of 510 over 2, that would equal 1 minus cosine 510 over sine 510. Why 510 over 2? Because that's the half-angle formula that will get us 255 degrees. Now, we know that a 510-degree angle is coterminal with what angle? Well, if you subtract 360, you get 150. So now you can magically transform this into 1 minus cosine 150 over sine 150. You can do this because cosine of 510 equals cosine of 150. Sine of 510 equals the sine of 150. And it's just easier to use numbers between 0 and 360. Now, let's solve this problem using these values instead. The cosine of 150 is negative radical 3 over 2. The sine of 150 is 1/2. Now, we'll combine these into one expression. 1 is 2 over 2, so this becomes 2 over 2 plus radical 3 over 2. Now, we just multiply the top and bottom by 2. That knocks out the 1/2, and at the top you're left with 2 plus radical 3. So you can see how much easier this was to do, and all you had to do was use the half angle formula instead. So if you see a problem like 2a, and you can try it with the half angle formula as well, you will see that it's generally easier to solve tangent problems using a half angle formula by just doubling the angle that you're given. Example 2c, find the exact value of tangent 7 pi over 8. Use the half angle formula here, figure out which angle of theta you're going to plug in. You can do that by doubling what this is. So we can use the half angle formula with theta equaling 7 pi over 4. So tangent of 7 pi over 8 is equal to 1 minus 7 pi over 4 divided by sine of 7 pi over 4. If you need to convert this into degrees, 7 pi over 4 is 315 degrees. So we're in the fourth quadrant, which means cosine is going to be positive, sine is going to be negative, and both reference angles are 45 degrees. So we plug in the values for cosine of 45 here. So 1 minus root 2 over 2 in the numerator. Sine of 45 is radical 2 over 2, but since we're in the fourth quadrant, we need to take the negative of that. So your expression is like this. Now, I turn the 1 into a 2 over 2, combine it to get 2 minus root 2 all over 2 divided by negative radical 2 over 2. Now let's multiply the top and bottom by 2, and we get 2 minus root 2 all over negative root 2. Now we have to get rid of the radical from the denominator, so let's multiply the top and bottom by root 2, and we get 2 root 2 minus 2 all over negative 2. Now we divide both terms by negative 2, and you get 1 minus radical 2. So that's the answer to 2c. Find the theta by doubling the original expression, and then plug the values into the half angle formula for tangent. 2d, find the exact value of tangent of 7 pi over 12. Do the same thing that you did in 2c to solve for 2d. So here theta is 7 pi over 6. So tangent of 7 pi over 12 equals 1 minus cosine 7 pi over 6 over sine 7 pi over 6. Now this corresponds to 210 degrees. So you are in quadrant 3. Both cosine and sine have a reference angle of 30 degrees, and both are going to be negative. So the cosine of 30 is radical 3 over 2. So we take the negative of that and plug that in here. Sine of 30 is 1/2. Take the negative of that and put that in the denominator. So now let's combine the expressions. And you multiply the top and bottom by 2. And notice that you don't even have to do it with the radical in the denominator. Your answer is going to be negative 2 minus radical 3. So a half angle formula is easier to work with in general than a addition formula. So instead of using the addition formula, you might be easier or better off to just double the angle and then plug it into the half angle formula. Finally, example 3. Tangent of alpha. If tangent of alpha is negative 3/4, find the tangent of 2 alpha. So now you're going to use the double angle formula. Plug in tangent of alpha and see if you can derive the correct answer. Alright, the double angle formula is the tangent of 2 alpha equals 2 tangent alpha minus over 1 minus tangent squared alpha. So 2 times negative 3/4 all over 1 minus negative 3/4 square, which is 9/16. So this becomes negative 3/2 over 7/16. Of course, when you divide by fraction, you multiply by its reciprocal. So negative 3/2 times 16/7, and you get negative 24/7. So these problems are pretty easy if you know what the tangent of alpha is. Sometimes you might be given the sine of alpha, and then you have to figure out what the tangent of alpha is. And that's a little more work. Alright, that's it for section 13.9. Keep adding notes and formulas to your flashcards or your cheat sheet. And if you have any questions, you can ask me in class while you're busily doing your world history or your chemistry homework.